Hey friends, welcome to the Health Via Modern Nutrition podcast, the HVMN podcast. This is your host, Jeffrey Wu. And today I'm super excited to speak with Dr. Jake Kushner. We talked to a number of physicians, number of scientists. It's relatively rare to have physician scientists in one package, especially someone with a background in endocrinology. So that's the field of hormones. We've talked to cardiologists, folks that looked at fasting more on the nutrition side. I'm actually excited to dive more on the endocrinology hormone side. So, Jake, great to have you on the program.
Thanks. We're really excited to be here.
Yeah. So I like to start from the very beginning. I'm sure as as a student going into medicine, what caught your attention in terms of endocrinology? What drove you towards, I guess, the overlap between endocrinology and metabolism, the current interest area that you have today? What is your story? What is your background?
Well, as an undergrad at UC Berkeley, I was a biochemistry major and very interested in metabolism and signals. And actually, there was a wonderful overlap in between metabolism and endocrinology and molecular biology in the era that I first got introduced to science. So in the mid 80s, a lot of the pioneers of molecular biology were endocrinologists. So if you wanted to sort of be a scientist who also studied physiology, endocrine was this great place to do it. And so I was interested in this. In truth, my dad is also a molecular endocrinologist. So I got to hear about all the cool things he was doing. And some of the first labs that I worked in were actually molecular endocrinology labs. So my dad was a postdoc with a famous guy named Howard Goodman, who was a sort of molecular endocrinologist. And then eventually I got to work with him at a biotech company in the Bay Area in San Francisco, which is now called SciOS, but was then called California Biotechnology. And I saw the sort of excitement around science and physiology and endocrinology. And so bizarrely, when I applied to medical school, I thought I was going to be a physician scientist studying metabolism or endocrine, which is rather specific, but that's actually what happened years and years later.
Yeah, super cool. I find that it's the best balance between, I think, if a scientist is too caught up in the ivory tower without clinical experience, it feels a little bit arrogant or niche or too focused. And then clinicians who sometimes become technicians on the front line who aren't focusing on the latest literature, following the latest research. It's very easy to get caught up in mechanics mode, right? You're just like the mechanic of the human body.
Yes.
So
Yes.
it is cool. And I think, and knowing a little bit of also your business background, also tying that into, healthcare as a business area, science, and active, having a clinical practice. I think it's a very interesting, at least purview to at least observe and comment on the evolution of health in our society today.
Yeah, and also I will say I'm a pediatrician, and I have this background in pediatrics. And for me, as a kid growing up, a big part of this was just this idea that I would ultimately find some way to advance science to improve the outcomes for kids. And clinically, I really enjoy my interactions with kids and adolescents and young adults. And though lately I'm not actually actively in clinical practice, I'm a real passionate advocate for young adult healthcare. And it's something I think we've really haven't done a good job of.
So let's talk about your experience at the NIH doing work on diabetes. So I would say that through the HVMN podcast, we've typically more focused on type 2 diabetes because one, that's chronic state that one can develop, right? As opposed to type 1 that is more congenital. So you can't really control that. And I think just within the backdrop, a third of us Americans are diabetic, and it's kind of skyrocketing. And there's ancillary discussion around insulin resistance, metabolic syndrome, that whole cascade of interesting research questions as well as clinical questions to talk about. I know you have more of a focus on type 1 diabetes, and I think that's a great way to just at least educate our audience in terms of the differences as well as why you ended up focusing more on the type 1 path.
Okay, so well, type 2 is very common, as you point out, in adults, and at least a third of people who live in Western societies are pre-diabetic. Maybe 10% have type 2 diabetes. Type 1 represents maybe a tenth of all kinds of diabetes, maybe a 20th. In the United States, the numbers are somewhere around 1.5 million Americans are estimated to have type 1 diabetes, and it's primarily an autoimmune condition. So these folks are otherwise metabolically healthy, and they will start to have signs of overt diabetes despite being typically normal weight. So there isn't an obvious predisposition to being overweight to then get type 1 diabetes. Typical age of onset, we used to think was around age 9 or 8 years old, but actually we can talk more about this later, but there's an unusual form of type 1 diabetes that we're increasingly aware of, which is adult onset type 1 diabetes. And that may be nearly as common as the more typical pediatric type 1 diabetes. It's just that it's much more difficult to diagnose. So the sort of typical type 1 diabetes, these are kids who are doing okay, and then all of a sudden they're a little bit thirsty, and then they might wet the bed at night, or they might have to run to the bathroom, and they're drinking a lot of water, and they're losing weight. And after a while, somebody thinks to check glucose, and they discover that their glucose is very high. And then they're whisked into the hospital, and somebody like me explains that they're going to require injected insulin to stay alive for the rest of their life. And they're going, what? Like, yeah, like, are you kidding me? My kid's fine. Like, we eat a good diet. And so that's really tough for them. So they're transformed onto this seemingly permanent trajectory towards injected insulin to sustain life. When I trained in endocrinology, I was at Boston Children's Hospital, the Harvard Medical School system, and we would care for all kinds of different endocrine things. We care for some thyroid, care for some kids who have problems making cortisol, care for kids who've had brain tumors and have trouble making the hormones that control growth. Okay, so we would do a lot of that kind of stuff, and that was maybe half of our work, and the other half was was diabetes. And most of the endocrinologists weren't that excited about it. It was sort of something that we had to do, but the sort of word on the street amongst my fellow pediatric endocrinologists was, yeah, it's kind of hard, and the families complain a lot, and it's really difficult to support them. And as a young pediatrician, I got to know these families, and I was just blown away by the unmet need. And so, whereas most people were sort of not so excited about caring for kids with diabetes, I just fell hopelessly into that and realized that was my passion, and that's what I wanted to do. So I cared for some kids, and I sort of served as the primary point of contact for 25 families and got to know them over my 3 years as a fellow. And I also began to think about a research career. And I went to work at the Joslin Diabetes Center, which is also at Harvard Medical School, and ended up in a lab run by a guy who studies insulin signaling. His name is Dr. Morris White. And at the time, we were funded by the Howard Hughes Medical Institute. It was a big, famous lab. And they studied all these aspects of so-called signal transduction, the stuff after insulin binds, and ultimately how it affects metabolism. And bizarrely, even though I was in what you would think of as a type 2 diabetes lab, there was a very cool observation that one of their mice was actually getting a model of type 1 diabetes. And so I became very interested in insulin secretion within this model, and I focused all my time there on the beta cells, that is the cells that make insulin within the pancreas, within the islets of Langerhans. And so when I established my research career, it was entirely around these islets, trying to understand their growth and expansion. And so I went from being an instructor at Harvard Medical School, basically working in a big lab and seeing some patients on my own, to then a faculty position at the University of Pennsylvania at the Children's Hospital of Philadelphia, where I established my own independent research lab. And then more recently, I was recruited here to Houston, Texas, where I served in the Baylor College of Medicine, running the Division of Endocrinology in the Department of Pediatrics. And so I've sort of done all these different things, mostly around kids and type 1 diabetes, but I've also been very much focused on basic science questions that relate to how insulin is made. And then more recently, some administrative work on how healthcare is delivered.
Yeah, which is like an interesting can of worms, which we think we can definitely talk about too.
Yeah. And then 2 years ago, I left And actually, I left academia completely. And now I'm working in private equity. So I work for a company called McNair Interests, which is the private equity firm that's associated with the McNair family. They also own the Houston Texans as a large private equity group. And we're doing investing in life science related entities. And we're especially focused on type 1 diabetes, as you can imagine, but also cancer immunology and other stuff. So I sort of think of myself as a physician who likes to read. And that's sort of what I'm good at, trying to think about complex stuff.
Yeah, no, I think it's cool to track that career path and trajectory. And I think if one is intellectually curious, I think being an investor is like a just one of the most fun jobs you can have because you're just learning and then placing bets, risk adjusted in terms of just helping create the future. So,
Yeah,
you know,
that's the hope.
yeah, that is the hope. But hopefully, you do well by doing good into the world. I did want to ask about your tenure at the NIH study section.
Oh,
I
yeah.
know that obviously NIH is kind of gold standard for a lot of academics. Researchers are just hoping to get like an R1 grant, and it's always like a crazy stressful process for our academic folks and friends. How did you get into position there at the NIH actually on the other side?
That was an unpaid position that I held as a chair of a study section. I had been funded by the NIH throughout my career. Initially, by one of these K awards. I had a K08, which is a physician scientist training award. It's sort of essentially it's like an R01, but it's smaller, and it requires you to have a mentor, typically a mentor who's a world class researcher. They're very, very competitive. And so when I was at Harvard Medical School, I wrote for one of these grants and eventually got it, not on the first try. And then with this KO8 grant, I was able to then continue my research in a more advanced capacity. And I eventually moved to the University of Pennsylvania with that as part of my initial support. I got another NIH grant, and then I got an R01, and then I got another NIH R01.
So these are multi-million dollar grants, just for context.
Yeah, multi-million dollar grants and super competitive, incredibly hard, really difficult to get funded by the NIH. Just brutally
I just
difficult.
want to make sure that people, not to be overly humble. I just want to give context to our listeners who aren't super familiar with the NIH process. That these are academia in some senses, very competitive in terms of dollars out there, and NIH grants are one super competitive. A lot of tenured professors, are missing. And they're like really, it's always a weird time of the year when people are like, oh, they can actually fund their lab and have students and actually do their work. And other times they're like, oh, crap, I have to downsize.
Yeah, I had been advised to participate in peer review from some of my mentors. They said, Jake, you should really get involved in judging grants because it's a good thing to do. And so I volunteered to serve on the study section. And the one that I volunteered was the one that judges these K grants, these grants for young scientific trainees. And so the very study section that had given me my first NIH grant was the one that I volunteered on. I got to know the the grants administrator, the SRO. His name is Dr. John Connaughton, and we became friends. And then he eventually asked me to serve on the grant panel as a permanent member, and I did. And then he eventually asked me to serve as the chair. And so I was involved in that study section for 5 years as a permanent member, plus all the other times I had volunteered here and there. And it was a really amazing experience. So we're basically looking at the next generation of young scientists who are going to work in metabolism or endocrinology. And these are not just physicians. Some of them are PhDs. Some of them are veterinarians. Some of them are psychologists. But these are the best of the best of the best. So it's actually an incredible opportunity because we're looking into what's going to happen in the future. And you see these people working in these spectacular labs using cutting edge techniques, or you see people who are flailing along in sort of marginal labs who don't have the right techniques. And it was really fun. I think for a young scientist, it's an amazing opportunity to serve in a study section because you get to see what the very best people are doing, and you get a sense of what the future will hold.
100%. So I do want to dive into your specific research and get into physiology, the biochemistry, all of that good stuff. But before leaving the topic of being on the standing committee, really helping pick and choose the next generation of research, I do want to unpack that a little bit in the sense that more just raising the question or having a discussion rather than making this more accusatory towards the system of peer review. But I think one of the common critiques I've seen is that, okay, there's this like gold blue ribbon panel of people that are choosing and picking winners. Sometimes the more speculative, out of the box thinkers are not selected because the gatekeepers want to kind of reward things that are much more incremental rather than the game changing paradigm shifting ideas. Obviously, you've played on both sides, and I don't, and again, not from an accusatory, this is me from outside in, just wanting to at least have the conversation around what was it like actually operating on that side. Did you sense that kind of crab pulling crabs down in the pot because they didn't want to like focus on research that was too speculative, too out there, too game changing? Can you talk about that dynamic?
Yeah, sometimes there's even just jealousy. Like a senior person is looking at a young person who has a breathtakingly innovative and exciting, though speculative idea. And you can see them sort of trying to push them into a box of, hey, you don't know, you can't prove, you aren't sure. I mean, I sort of think of that as the cult of incrementalism. There's a group of people within science who are trying to make sure that it moves forward tiny step by tiny step by tiny step. And the people who make these really big these giant leaps forward in the field wouldn't necessarily get funded by an NIH panel. And many of the recent Nobel Prizes in chemistry and in medicine, I'm just not convinced would have withstood an NIH panel. Because again, they're based on an outlandish idea that moves beyond where the field is. So this is tough. I don't know that everybody has struggled with this in peer review. Because if you're the person sitting in peer review, you have to come up with some objective assessment as to why this grant is better than that grant. And in truth, everybody knows that only 10% of the grants are going to be funded. So that's kind of hard. I think of that in fairness, this is probably a dysfunctional response to a dysfunctional situation. If there isn't enough money in the system, people are going to be freaking out and making bad decisions about what can be funded. If there's a little more money in the system, I would bet that reviewers might be a little more generous and allow more freestyling. And nobody, but this is a fundamental problem that society has, which is that we tend to judge.
How do you choose resource allocation?
Yeah.
Which is an interesting, I think, I mean, just as we're talking about resource allocation, it's interesting to see that you're now on the private equity side, which is more of a financial return selection of grants, essentially, if you will, for equity, right? Which I think is an interesting evolution from picking government money to distribute versus picking private money to distribute.
It's essentially probably the same thing. And there is this really important question. So one question is what's the rate of return? But another question is what's the potential impact on society? And those two questions may not be synonymous, right? So a safe bet for an investment or a safe bet for an NIH grant may not be the same thing as if we invest in this idea, could we have an outlandish and amazing return?
Yeah, and that's where I think folks who have more of a venture experience where you get like the 1000x societal return, but you have a 1% shot of making it, the expected value is, X. And then if you do a more incremental change, expected the variance is much tighter. So you have a more expected rate of return, but you're not getting those outlandish, like paradigm shifting creations or inventions or discoveries. Maybe one thing to further comment about, because I think this is like something that I think is not spoken about enough. And I think I appreciate your context in terms of unpacking some of the incentives within the peer review process, is that the peer review process is actually a relatively recent phenomenon in science, right? Like Watson and Crick, when they discovered this molecular structure of DNA, was not peer reviewed, right? It's like no one was peer reviewing Einstein's theory of general relativity, right? Like no one even how to assess it. And I think it's very funny to me. Not funny, it's just like an interesting observation that now with especially when science is more at the forefront given COVID-19, everyone's talking about peer review, it's gold standard. It must, everything science, all we've known is these peer reviewed things. And I think peer review is a very, very useful tool, as you mentioned. It just, but peer review is a relatively recent phenomenon. And I think the dynamics you described around jealousy, like the people that are peer reviewing are also humans. And I think just my intersection with academia, I think I just had a more naive outlook in terms of scientists or researchers where it's like you treat them as not as people. And but if you realize that everyone's a person, everyone has emotional state and interest and potential jealousy or not jealousy, that I think that's just like more of a realistic, I guess, interface with what we should expect from the scientific community. And I feel like being just transparent around the incentives hopefully just makes the relationship between the lay people, this general society at large, with scientists, and realizing, hey, scientists are people too. They have a lot of education and knowledge, but there's also kind of that weird incentive that is like unspoken about. I'm curious to hear your opinion, just like talking about peer review, the evolution of why peer review is like such a dominant framework within science today, or the modern industry of science. And then what would be a better system if we could speculate on, we're the gods of academia. How would we potentially manipulate the incentives in a more productive way?
Okay. This is a great question. Back in the 70s, the limiters were primarily in getting a faculty position. So these regional med centers that didn't have huge research labs. And so if you went around in various states, you would not find the research institute of this or that. And in fact, much more of the NIH funding was concentrated in a few places. And so the gatekeeper there was simply getting a faculty position. Once you had one, you could write an NIH grant. It was like one page. You're like, hey, I got this really cool idea. And they're like, oh, cool. That sounds good. There's the money.
You're part of the club. You're part of the club, and then they give you the money.
But the jobs were hard to get. And, you wanted to be at a place like Harvard or Stanford or something else, and they might have 100 people applying for one job. Now what happens is these jobs are all over the United States. And people are able to get these jobs, but then they're told, okay, you have a soft money position, and if you're able to get a grant and cover your salary, you can stay. So that's just created a huge pool of scientists, some of which are, frankly, it's just more incremental because there's so much competition. Harvard is still Harvard, and there are wonderful people at those places. But I guess you could argue that it's made science more democratic and that it's coming from lots of different places. But it's also less elitist. That's both good and bad. All right. So all of these incentives have changed, but now, science now is extremely competitive. The NIH grants are funded at less than 10 percentile. Thankfully, something else really exciting has happened, which is that philanthropy has come up to add to this. So a much larger percentage of research portfolios are paid for by philanthropy. There are people with very specific ideas who end up supplementing successful researchers with philanthropy. They'll say, hey, I have this idea. I want to support this person, or I love this person. I just want to support them with unrestricted funds. And that can make an enormous difference. And that didn't really exist in the 70s. So it's both good and bad. Science is moving along really fast. If COVID-19 has told us anything, is that the scientific enterprise, the global scientific enterprise, is vibrant and dynamic and capable of approaching really difficult problems.
Do you have any concern about replication?
Yeah.
I think there is more creation of knowledge, but again, I don't have any data, but my suspicion is that there's a lot of fake data too. And I think it's just like, I think directionally we are learning more about the world, but I'm also, I don't know if it's skeptical, but I'm also just aware that we also need to make sure that we're, I don't know, like there's been a number of retractions and things where you're like, oh, okay, like you can just fake this stuff, right? No one's checking deeply enough.
This is a huge problem. And unfortunately, there hasn't been enough emphasis on transparency. I don't know. We realized this early on when I started my research lab that no one was embracing transparency. And so in many of the papers that we've published, essentially all of the papers over the past 12 years, we published these appendices, these huge Excel spreadsheets where we would actually describe the identity of the mouse, like the individual number that the mouse was given, the date of birth, the actual date of the test, the result of the test. And you typically don't see this in a lot of experimental papers, that there aren't those details available. My hope was that just to be fully transparent about everything that we had so that young people could go back and sort of figure out why we made the conclusions that we made. There is a problem with reproducibility, and part of the issue is that there's no accountability. And part of the issue is that we're a brand conscious society. So everybody wants to get into these fancy journals, and one more fudged experiment that might push them over the bar to get them in a fancy journal. And that stuff is really toxic and awful. And it does exist where people are manipulating their science to get in fancy publications. It's terrible.
Yeah, I mean, I think it just like, not to critique that everything is fake, but I think it's just like we just understand the incentives, and I think it is a competitive environment, and I think, as you're saying, like, no one wants to publish a null result, so there's an incentive bias, or saying, "Hey, I discovered something," rather than, "Hey, I showed the 17,000th method of something not working." Right? That's not sexy enough to get published in Nature or Science or whatever the top journals of their field might be. So yeah, I mean, is
Yeah.
there? My hope is that
We actually got rejected from Cell with a paper that refuted a Cell paper. So we had a very well-designed experiment that expressly refuted a really important result that was published in Cell, which is a top journal. And they like I said, they just weren't interested in that negative publicity.
yeah, because that's interesting
That paper's
dynamics,
been
right?
cited like 100 times.
Yeah. I mean, can you share more about that study? I think our listeners might be interested in just kind of like the experiment and the result. And
All right, so we're trying to understand how the pancreatic beta cells grow and divide. And an outstanding question was, what are the major signals that promote the growth of these cells that make insulin, the beta cells? And we hadn't always known that increased metabolic demand, like obesity, causes the cells to grow and divide. And pregnancy is another very strong stimulus. We could also even do forced regeneration by doing a surgical resection. So we could cut out half the pancreas, and then the remaining beta cells would grow and divide. So we had a sense that there were a few very prominent physiological signals. And then a paper came out in Cell describing that pancreatic injury caused a massive, massive growth of the beta cells. And what they had done was they caused a pancreatitis, where they tied off the pancreas, forcing it. Essentially, they plugged up its drain, and then the pancreas essentially eats itself alive. So there's this process is called pancreatitis. And after this massive pancreatitis associated inflammation had died down, they looked at the cells that make insulin, the beta cells, and they said, "Oh, there's a massive increase in the number of beta cells. We can see evidence of cell division. Therefore, this pancreatic injury is causing regeneration of the beta cells." And they went on to assert that it had occurred via a very unusual stem cell-like mechanism. So we looked at this and we're like, I don't know. It doesn't quite make sense. It was all happening too fast according to their kinetics. It sort of violated some of the speed limits that we had seen. So we set off to replicate it. And we did this a big experiment with a whole bunch of mice. We had to learn the technique of causing the pancreatitis. They call it pancreatic ductal ligation. So we learned to sew the pancreatic duct and to clog it up. And we do this experiment, and then we count the number of beta cells, and we count the number of dividing beta cells. And it was the same. And we're like, what? You're like, wait a minute, we're supposed to be confirming their result. And so we went back and we did it again. We got the exact same thing. And so then we submitted our paper as a refutation of the original paper itself, and it got slammed. Now, what we actually think happened was the original author was one of the reviewers of our paper.
oh
And he was
yeah,
like, "Oh yeah, these guys
I was
are
gonna say
idiots."
I mean, that's part of the game, right? It's just like you're basically calling me a fraud. F you, right?
Right. And the
Was there
problem was
reasonable critique on your procedure, or was it just BS? Like, I can just to give that person like a fair shake. Was there a reasonable critique?
oh, this is a great question. Well, what they said was, these guys don't know how to do it. And we said, no, actually, we do know how to do it. Look at all this evidence that it had worked. It's true pancreatitis just like yours. And here's all our controls. We had a bazillion controls, and we had counted a bazillion mice compared to them. So much more quantitative rigor. And then we appealed, and then they blew us off. And then finally we accepted the rejection, and we had to go to another journal. And it was eventually published in Diabetes. We got the cover of Diabetes, and it's been cited over 100 times. And the paper that we were attempting to refute is still out there, has never been retracted. Most people in the field don't believe that it's true. It hasn't been confirmed by any independent lab. The primary assertions have never been held up, and yet it's still out there, and it's like a crowning achievement of one lab's career. So that's kind of weird because, well, you could say, well, that's bad because science doesn't correct itself and there's a bad paper in the literature. And by the way, there's many other people who agree with me who also had similar findings that our lab did, that this pancreatitis doesn't cause beta cell regeneration. But that's just the way it goes. Journals don't like to take down articles that have been published for a while. They're like, well, we'll just let the literature sort it out. But that's a problem because it means for the uninitiated, the people who don't understand this field, they may falsely they may find a paper that everybody knows is false, read it, and accept it as gospel. That's a problem.
Yeah, I mean,
I don't know how to fix that.
yeah, I think my perspective is that I think there's a great push for more open access journal articles. I think people are more and more savvy. I mean, just to our listeners, people are pretty damn savvy. Like they don't necessarily have like the actual degrees, PhDs, but they're reading papers and starting to build up that skill set of actually understanding kind of the mechanisms and what are reasonable controls. And I would say that, obviously the formal training is valuable, but one does not necessarily, it is not a requirement to go through formal training to have the same tools of science, right? And I think one comment that went viral was that we have to remember that science is not an appeal to authority argument. End of the day, science is finding what is true, and that just ticks some people off, and we can go down that rabbit hole. But I truly believe that almost every single paradigm of science, from Copernicus, Galileo, Newton to Einstein, Watson, Crick, that was against the authorities of the time in terms of paradigm. So I think science is the rejection of appeal to authority. I mean, that's by definition, like we're redefining what is the paradigm. So my hope is that there's a democratization of access and information, and we have more of a educated community, and these gatekeepers or these authority figures will have to be judged on their accuracy and their reputation. And I think honestly, not just even in research, I think it's happening with media, with traditional bastions of authority. So I think it's a very interesting time in our culture, civilization broadly, where I don't know, there's some weird questions around, whatever media outlet, whether it's Fox News to the New York Times or whatnot. It's like, are we focused on the brand or the actual individual work itself? And hopefully we move to a world where the work itself is what's judged.
Yeah, I became a huge fan, by the way, of PLOS, the Public Library of Science, and we published a lot of stuff in PLOS One, which is their open access journal, which some people have denigrated as not that prestigious, but the reality is it can be read by anybody on the internet, and when you erode those barriers, more and more people read your stuff. So, like as far as I can tell, like that's all good. Get more stuff out there, allow your work to be effectively judged. The other great advantage of a journal like PLOS One is there's no page limits. So you can throw all the stuff in it as opposed to having some artificial restriction. I mean, yeah, ultimately, the way to judge science is by its impact, by the number of times that it's referenced, and ultimately how that information shapes the future. So I'm much more proud of the papers that we published that have been cited more than 100 times than I am of the papers that went in prestigious journals and weren't cited that many times. Because it's about impact. It's about shaping hearts and minds.
Yeah, and hopefully we have an infrastructure incentive that promotes behavior like you're describing. And I think that's the incrementality issue with, okay, I need to get my, my Stanford faculty position. I got to like spam prestigious journals. And it's like, yeah, I think it's beyond the scope of this conversation to help solve, but I think at least just bring awareness to what are infrastructural issues. And I think with the open source, I feel like it's going the right direction and I think folks who are fighting against it feels very medieval. Like it reminds me of it's the priest who wants to keep the Bible for himself or herself, and I'm gonna give the translate the word of the gospel because you uneducated masses are not worthy or not educated enough to understand. And obviously, fast forward in religious history, obviously a lot of people have now a direct relationship with their creator. And I think science has always, been a counterbalance to that, where everyone can be a scientist. There's no, like, God doesn't tell that you're a scientist, you're a chosen one, or you're not. It's a tool set, a thinking framework to understand the universe around us. And everyone should be able to access that. And I think when people are elitist about it, it's like you're being anti-scientific almost.
Now, this is actually one of the great achievements of Dr. Francis Collins, the NIH director, who has pushed open access for years and years and years. And he was provoked to do so in part because there was some kid who was researching a particular topic who I think was in high school, and wrote to him to complain that a bunch of the things that he was interested in, that had been funded by the NIH, were inaccessible. And Francis Collins embraced that. That's cool.
Yeah, so I want to go directly into your research areas. We talked a little bit about the interesting, the beta cells, but if you could kind of give at least the arc of your research direction, your themes, that could be just an interesting jumping off point as we go a little bit more into physiology now.
All right, so I'm caring for these kids with type 1 diabetes. I know that their care is really challenging. They have to inject insulin and measure glucose, and it's really difficult for them to stay on target. And I'm thinking, I want to understand the way these cells are made, because maybe we could figure out a way ultimately to regrow their beta cells, if we could ever find a way to shut down the immune system. So I'm imagining myself as a young physician scientist, as somebody who will focus on the beta cell. And I'm going to figure out all the things that trigger their growth or survival. And I want to understand their progenitors. And I want to understand the major mitogenic signals that impinge upon their growth and expansion. And so that's why I went and worked with this guy, Morris White. And that was really the major focus of my lab at UPenn. And we studied insulin signals, which are very, very prominent. The IRS2 branch of the insulin signaling pathway, which appears to be absolutely essential for beta cell growth. We also studied something called PTEN, PTEN. It's the so-called tensin homolog, and it's a modulator of PI3 kinase signaling. So I got very much into that whole pathway as it relates to beta cells. I also then started to look at some of the downstream effects, transcription factors that might be mediating these effects, as well as these cyclins, these things that are involved in cell cycle entry. And when I established my lab, the goal was to find really potent mitogenic signals. But something happened along the way that sort of I think of as my existential crisis, which is I'm looking for mitogenic signals that could potentially cause beta cells to expand. And we started looking in older mice, realizing that very little was known about their regenerative capacity. And we discovered that the beta cells of mice that were, say, over a year had almost no capacity to re-enter cell cycle and to grow. And that made me very worried that any potential regenerative therapy might fail if it was applied to adults. And after all, adults are most people with type 1 diabetes are adults, right? So if you wanted to try to regrow their beta cells, you'd be regrowing them in adults, not in kids. But then I just discovered that when we experimentally looked at these beta cells in adults, we couldn't see cell cycle entry. And fast forward many years, when we discovered that regeneration of beta cells was strictly limited in aged mammals. And it seemed to be true not just in mice, but also in dogs, and even in the few autopsy specimens that we were able to study in man. And then we also looked in diabetic conditions such as type 1 diabetes and type 2 diabetes. And we saw very little evidence of cell cycle entry, that is, expansion or proliferation of beta cells. So in my field, I started to get the reputation as the guy who says beta cell regeneration can't happen. And I was sort of the party pooper. This is kind of weird because, again, back in 2006, if you Googled my name, you would find beta cell regeneration. Or if you Googled beta cell regeneration lab, you would find my lab. And yet, around this time, we were beginning to realize that this target might be very difficult to achieve. So that triggered a crisis in confidence for me because I wondered, like, what am I doing? Like, what will I ever achieve if I spend all my time trying to achieve something that is, impossible? Am I just wasting a career? And I was still, still a clinician, still caring for patients. I really enjoyed caring for these kids with type 1 diabetes. And so that was why I decided to become an academic administrator, because I thought, well, if I ran a division and I ran a healthcare center that delivered diabetes care, then I could shape the care to ensure that the kids, at the very least, got the very best available, in addition to moving science forward. And so that's why I came here to Houston. But that's also how I got interested in metabolism and low carb. And because what happened was, along the way, listening to people with type 1 diabetes, I discovered these very bizarre stories of people who had type 1 diabetes but were consuming almost no carbohydrates, and their blood sugars were just incredibly smooth. And when I saw those stories and I learned about it, I started asking around to my peers, and none of my peers knew anything about it. The few who did said, oh, yeah, all those low carb people are crazy. And I said, well, wait a minute. Do you know of any other way to get near perfect blood sugars? And they were like, well, no, but they're crazy. Like, don't listen to them. It's dangerous. And so I fell into the rabbit hole, thinking about low carb, reading about it, talking to people. This is probably maybe 8 years ago. And I've been obsessed with the topic ever since. And essentially, the conclusion that I've come to is, if you have type 1 diabetes, and you look into the toolbox, it's a relatively limited number of tools. You got insulin, and maybe you could have a better insulin pump. You could have a glucose monitor. They have these things that can measure glucose continuously, these so-called continuous glucose monitors, or CGMs.
We've played around with them for, as hobbyists. So.
Yeah, they're fabulous, right? And for people with type 1 diabetes, it's a game changer. So you have an insulin pump and a CGM, or you could combine the two, and maybe you could have a smart pump. And then potentially you also have the possibilities of exercise, but that's about it. And if you look at what a smart pump does, that is an insulin pump that's hooked up to a CGM, the outcomes are not great. So most of those people with type 1 diabetes will, on average, have a hemoglobin A1C somewhere around 7.5%. So that's still going to put them at great risk for complications later on in life. But on the other hand, these amazing anecdotes of people who are on low carb and have type 1, some of them are able to have a hemoglobin A1Cs under 6%. So in the normal range. And that's unheard of. If you just take the general population and you throw out all these low carb zanies, what you find is that there's essentially no one who's able to keep their blood sugar under 6, with a hemoglobin A1C under 6%. So, I got more and more interested in metabolism, but we still have a long ways to go. I mean, there still hasn't been a good randomized controlled clinical trial for low carb with type 1. There's still very little acceptance in the traditional low carb, in the traditional pediatric endocrine or adult endocrine community with low carb. There are barriers.
Yeah. No, I think it's interesting in terms of I think from a scientist perspective, one has to figure out when you have observations that break the framework, then you have to update the framework, not dismiss the counterexample. And I feel like that's where I just sometimes look at scientists that have the scientist hat on. It's like, you're not very scientific when it's like you're dismissing real signal. Like, oh, this is just anecdotes. And it's like, maybe people made it up. But if there are enough anecdotes where you're pretty confident people aren't making this up, then potentially your framework of understanding why these observations are happening is not fully capturing that picture, right? That's how, Einstein was able to realize that Newtonian physics, you're not capturing these edge cases, or quantum mechanics, you're not capturing these edge cases. The same thing I think is happening here, where we have like a pretty good, effective framework of understanding type 1, type 2 diabetes, but you're having these edge cases that are not described with the current context. How do we update our thinking to incorporate this knowledge?
Yeah, there's a big problem in modern medicine where form dictates function. It's like, well, okay, so you have diabetes, so you need to go to a diabetes clinic and you're going to meet with a nutritionist and they're going to tell you their best estimate of what you should get. And you might be able to meet with a social worker and they're going to tell you their best estimate. And everybody sort of contributes. And then you end up with the tyranny of the mean. Basically, you're going to get this weird average in terms of the clinical product that is delivered to the customer, the patient, as opposed to sort of asking a much broader question, which is what are the range of potential approaches that we could take that would help you to live the very best life? And for me, the most important outcome is actually not glycemia or glucose. It's self-reported outcomes. It's how people feel. With type 1 diabetes, the burden of living with the illness can be very high. And a lot of people describe a lot of stress and anxiety associated with just the day-to-day fear of living with blood sugars that are quite volatile and the work associated with doing all this. So from my standpoint, the most important thing is when a person describes that their burden is low and that they are satisfied with their life. And that definition, in a way, also encompasses glucose, because ultimately, if you are satisfied with the way things have gone, you'll have low complications. Of course, you'd have to carry out that assessment for somebody's whole life. But again, I think it's like a balance of self-reported outcomes and hemoglobin A1C. And I've always looked for the solution that allows people to feel great about their lives and living with this illness, and also minimize risk of complications. And it's not just, low carb is just one tool, but it's everything.
Right. And I think that's super sensible in the sense that if you have just elevated hyperglycemia for a long time, you're going to be likely for all these chronic diseases, cardiovascular, et cetera, that relate to just the baseline of hyperglycemia. So it's kind of the overall quality of life over that extended period of time makes sense. Yeah, no, I think just anecdotally, like I remember just talking to a lot of athletes who are type 1 who have used more of a low carb approach and are pretty competitive athletes. So again, from an anecdotal perspective, it's very interesting that people are starting to experiment with ketogenic approach to managing type 1. So hopefully that's, I think I agree with you completely. It is one tool. It is not the only tool, but should be a tool that is discussed amongst the existing standard of care tools.
Yeah, and there's some incredible theoretical benefits of going low carb as an athlete if you have type 1. So a major problem for people who have type 1, who are athletes, is they will exercise a lot and then they end up basically invoking a second mechanism where the glucose is taken up by the muscle in an insulin independent manner. So exercise it sort of serves as a sponge to suck the carbohydrate out of their blood into their muscles with that insulin. And
is it still going through GLUT4?
Yeah, it is. It's still going through GLUT4, but it's going through, but it's AMP kinase.
But it's just driven. It's not insulin mediated.
It's not insulin mediated.
It's what
That's
driven?
Right. By this enzyme called AMP kinase.
Okay, AMP.
At least in part. And so there's a terrific biochemist at the Joslin named Lori Goodyear who studied this most of her life, and so exercise has these amazing effects on this insulin independent pathway. And so this is a very potent pathway, and it's endurance exercise related. So really interestingly, there are people who have carb emphasis diets who are elite athletes, like for instance, Kenyan runners have 85% of their diet maybe from carbohydrate, but they still have a little bit of ketones, which is kind of bizarre, right? Because if you're eating mostly carbs, you should have lots and lots of insulin, and the insulin would then be suppressing your ketones. But I think what's going on is in these elite athletes, they have this mechanism where they're always sucking carbohydrate up in this insulin-independent manner into the skeletal muscle. So it's almost as if they're keto, right? Because they're partitioning their carbs without insulin. And so for a person with type 1, that can be a challenge because then there's a lot of glucose volatility that's associated with exercise. And if you're on a high carb diet and you have type 1 diabetes and you go out for a 10-mile run, you're going to have to carry a handful of carbohydrates just to keep your blood sugar in normal range. And so the advantage of low carb is, in a sense, what you're doing is you're retraining your metabolism so that you're burning fat instead of carbohydrate. So now your muscle is in part being driven by fat oxidation. You go out and exercise, you don't have the same extreme lows associated with exercise, and you can keep running and running and running without consuming exogenous carbohydrate. And this is also a mechanism whereby elite runners who don't have type 1 diabetes, many of them have adopted the nutritional ketosis. And have you guys had this guy, Zach Bitter, on your podcast?
Yep. I've talked to Zach. Yeah.
Zach is incredible. So Zach is the world record holder for the indoor 100 and the 100 on a treadmill, and he's fat powered, and he consumes very little carbohydrate in the middle of these runs. I mean, it's mind blowing. So what he's doing is he's burning fat, and so there's a huge advantage because then he doesn't have to refeed.
Yeah, no,
That's
I've
wild.
seen elite athletes that never even have the lactate. They never cross the lactate threshold, where even if they're like max VO2 max, they're still predominantly fat burning or aerobic burning, which is pretty incredible.
Yeah, this Volek and Finney, have you had them on your podcast?
We have not had them on, but I know them personally on a personal basis. Yeah.
Yeah, so Jeff Volek and Steve Finney were the co-founders of Virta Health, along with Sami Inkinen. And Volek and Finney did this thing that they call the FASTER study, which studied these elite athletes in various contexts, including, I guess it was the Western States 100. So they went and watched Zach Bitter win. He apparently won by an hour, and they did various metabolic tests. And he consumed, over the course of this entire race, 100 miles, 30,000 vertical foot climb, he consumed like less than 100 grams of carbohydrate. Just magical. Totally incredible.
Yeah, it's super cool. So I think from there, in your research or just post type 1 world, how important was ketogenesis, ketosis, exogenous ketones, or like just the signaling properties of beta hydroxybutyrate itself was to your work? And well, I'll just keep the question simple there in terms of just opening up into just general ketosis.
We haven't really studied that, to be honest. And to be fair, in the type 1 community, there's a lot of anxiety about ketosis.
And ketoacidosis.
We should probably unpack that because of ketoacidosis. So what is diabetic ketoacidosis? Diabetic ketoacidosis is a life-threatening condition of insulin deficiency in somebody who's type 1. So if somebody has type 1 and you take away their insulin, what happens is they build up ketones, they build up more ketones, and they go into a state of uncontrolled catabolism with very high levels of ketones, with lactate, extreme acidosis, and then these immense changes in anions, cations, et cetera, and they can die. And these people will eventually pass away with a pH of 6.7 and a heart that's not contracting well. And that might happen over a period of a week or two, or in some cases, only 3 days. In other cases, people will die from cerebral edema. We don't really understand that mechanism. So in the type 1 world, we're thinking about diabetic ketoacidosis, or DKA as we call it, as a signal of insulin deficiency. And because of that association, many type 1 diabetes docs, many endocrinologists, will say you don't want to ever have ketones because it means you might have DKA. But there are people who have type 1 who are on low carb diets. Most of them are on low carb, high protein, and they're not really in ketosis. Like the famous Dr. Richard Bernstein advocates a low carb, high protein diet that, and when he measures his ketones, his beta hydroxybutyrate is like 0.3 millimolar. So it's not that high. But there are other people who have type 1 who are explicitly pursuing a strategy of nutritional ketosis, and they might get their beta hydroxybutyrate up to 1 millimolar or even higher. So is that a problem? Well, the simple answer is we don't know. What I can tell you is that these people appear to be fine, and they generally report that they enjoy their life of being in nutritional ketosis and having type 1 diabetes. there are some potential dangers, and it's worth mentioning them. So, for instance, one is if your beta hydroxybutyrate is always 1 millimolar, and then you have a problem with your, say, for instance, getting insulin because your insulin pump clogged or you forgot to take a shot, and you're sliding into diabetic ketoacidosis. Well, if you check your beta hydroxybutyrate and it was 1 before and it's 2.4 now, you may not know that it's on the rise. So I think monitoring beta hydroxybutyrate is exquisitely important for a person who is pursuing a low carb strategy, especially in nutritional ketosis who has type 1. Because you really want to be able to diagnose a beta hydroxybutyrate that's going high and higher and higher as a, to realize that you're in trouble.
Yeah, I think we need a beta hydroxybutyrate continuous BHB monitor, just like there's CGMs. We need a continuous ketone monitor, and I know a couple groups that are working on that technology now. So hopefully we can actually dial that in. I think in the future, hopefully we just have continuous analyte monitoring across a number of different analytes, which would be just that dream of real time data and real-time interventions in terms of optimizing performance and health. Yeah, no, I completely agree with your assessment there. I remember the first time I Googled ketosis, probably 6-7 years ago at this time, the first result was diabetic ketoacidosis. And I was like, why do you want ketosis? Isn't like literally when people are asking me like, oh, I'm excited about this keto thing. They're like, isn't this bad for you? I'm like, huh. And it is very cool to see within, those last 5 years. It's the perception has changed, but when you don't have insulin, that's kind of like the negative feedback loop that stops the runaway creation of ketogenesis. So that's the problem, the type 1 edge case that I think is worthy to note. I think one thing that was super interesting, because I've just had the opportunity to just do a lot of just kind of experiments with friends or people, was that I had a type 1 diabetic who didn't take his insulin. I didn't know this, to try an exogenous ketone ester.
Whoa.
And
Huh?
and like he just it acutely lowered his blood sugar. It was from like around 180 milligrams per deciliter. We dropped it to like 130 in like 30 minutes, 60 minutes. So I think there's definitely some sort of insulin-like mediating factor. I think he just didn't take his insulin that overnight, so I don't think his ketones were that high. So like, if I had known that he was doing that, we probably wouldn't have done that experiment.
We don't really understand the myriad effects of beta hydroxybutyrate on all these pathways. But again, if this was a person who had a little bit of endogenous insulin, so some people with type 1 diabetes, they make a little bit of insulin. So they got it as an adult. There's an adult onset. They might have a tiny capacity, and it's possible that the exogenous ketones would tickle the beta cells to make a little more insulin. Or alternatively, it's possible that the exogenous ketones would interact with some peripheral mechanism, like in the muscle or the liver, right? And I'd love to see more of this. This kind of work needs to happen. I also want to see better research on keto adaptation. I mean, there's some perplexing things, like people who are keto adapted tend to actually have higher fasting blood sugars than before, which is kind of curious.
Yeah, I've seen that where people have, they have over 100 milligrams per deciliter fasted blood glucose, but their fasted insulin is like 2 units. And it's just like, interesting. Like, this is not like the type 2 diabetes with high fasted insulin and high fasted blood glucose.
I think that happened to me. The few times I've had my labs checked, I don't know if you guys have had Dave Feldman.
Super smart
but
dude.
he's a friend of mine and a brilliant character. And so I participated in one of his group blood draws, and my fasting blood sugar was like 92, and my insulin was super. I'm in nutritional ketosis, as you can imagine. I've been in nutritional ketosis for about 4 or 5 years now, and I just became totally. The problem was I had been thinking about it and reading about it, and I became convinced that it was likely going to confer long-term benefits to metabolism. I'm the kind of person, and I thought, well, I should just try it and see what it's like. And once we got into it, we discovered actually that there was a whole range of food that we had never considered that would keep us in ketosis. And so, fast forward 5 years now, and we're still in a very low carb. Both my wife and I and my 2 daughters are low carb, and both my wife and I are typically, we have beta hydroxybutaраtes around 1. I mean, and I haven't had
That's pretty solid. That's solid nutritional ketosis.
I have not had a big plate of pasta in 5 years.
That's super commendable. I think I'm curious to learn and hear about your current protocols, both from a time restriction, diet or calorie restriction. I mean, the dimensions, right? Macronutrient dimensions. Whether you are thoughtful around, intermittent fasting or exercise. What is your current protocol these days? I mean, for me, I've really kind of landed more on a cyclical. I'll do blocks of keto, and then if I'm doing much more exercise, I've been, kind of more of an active guy, will have introduced more carbohydrate. I find that it's very easy for me to shift back and forth in terms of having that metabolic flexibility after being keto adapted, having done long extended fasts. Like if I have a bolus of carbohydrate, I dispose of it very, very quickly and can get into ketosis pretty quickly the next day. And I imagine that's kind of the goal. It's not to say one needs to necessarily be in permanent ketosis or not or never go into ketosis. I think an important metric is the metabolic flexibility to use whatever energy substrate that your body is confronted with.
I was thinking about the relationship between saturated fat and the LDL cholesterol, and the relationship between LDL cholesterol and coronary artery disease. And I came to the conclusion that monounsaturated fats were probably better. And the more monounsaturated fat I could get in my body, the less propensity I would have to drive my LDL up. And let's just call
So this is like avocados, right?
Yeah, exactly. So I was essentially trying to waffle in between that hardcore keto, don't worry about saturated fat, don't worry about LDL, and my sort of traditional physician side, which said, hey, statins probably do confer some benefit. So I had read on Peter Attia's blog about macadamia nuts and their macronutrient content. And so I fell down the rabbit hole of thinking about different kinds of macadamia nuts. And so we ordered these macadamia nuts from Hawaii in vacuum sealed 4-pound bags. It's called Hamakua nut, or Ha nut, HAWNUT, hanut.com. So Hamakua nut, I order them and basically I keep them in the fridge. I buy about 16 pounds at a time. It's totally crazy. And I eat this for breakfast every morning along with black coffee. So that's what I eat every morning pretty much. Maybe 90% of the mornings. And then I'll have some low carb lunch. It might be salad with a bit of fish on it. And I make my own aioli with avocado oil. So my whole thing is to try to jack up the amount of fat in the meal. And if you are making your own aioli, which is essentially mayonnaise, you can make it super flavorful. So I have a friend who grows mushrooms, and he's been giving me this powder from this lion's mane powder. So I make what we jokingly call nootropic aioli, because the lion's mane has been claimed by some, I'm not sure I believe it, to be nootropic. I don't know what that means, but it tastes good. So I'm taking the lion's mane powder.
I haven't seen really good human RCT data on
it. Nor I. But it tastes good. So we make this aioli with some lion's mane and some lemon juice and a little bit of garlic and salt, pepper, and I'll dump that into a salad with some fish or something else, maybe some cheese. And then for dinner, we're making lots of things like we used to make, maybe a lasagna, but instead of having noodles, we'll have zucchini noodles. Or if we go to Chinese takeout, we'll order a bunch of dishes, but we don't get rice. So we're sort of trying to think about the things that we used to eat using, with the palette of foods that we like. But my general rule is to jack up the fat content. So if my wife makes lasagna and it's got, some sausage and some cheese and some zucchini noodles, I will dump more olive oil on the top. I try to add oil to the limit of palatability. And so the goal is just to jack up the fat content.
Yeah, no, I think it's an interesting, I would say, sub-school here that I think obviously there's folks on more the carnivore side who are eating a lot of saturated fat from animal content. I mean, if you're willing to share, I mean, how is your triglyceride, your lipid panel look like? I mean, are you able to control kind of the LDL levels with having more monounsaturated fats in your diet. I think I don't have a strong opinion here in terms of carnivore saturated heavy diet versus more avocado monounsaturated fat content or nut fat. Yeah, I just I'm kind of agnostic on that, but I'm curious in terms of just like teasing into that point a little bit because I know that that's kind of the main two schools within the overall keto community.
I'm actually going to pull up my lab so I don't make a mistake. But I've had my labs done with Dave Feldman now twice, and so the first time I did it, I guess my total cholesterol was 185 and my LDL was 107, but my triglycerides were 49 and my HDL was 68. My VLDL
It's
calculated
pretty
was
pretty
10.
damn good. Sounds really good to me.
My circulating insulin was 2.4. My C-peptide was 1. My LP little a was 3.4.
So yeah, very very low
Yeah.
inflammation, very very low fast insulin.
And my C-reactive protein was like 0.62, so like super low. And my A1C was 4.8. I've had that essentially that same panel done with the more sophisticated fractionation, where they look at the
Like LDL particle sizes and all
yeah,
that
my
good stuff.
LDL particle was 1086, which was on the high-ish side. I don't know what that means, but essentially I have it looks like I have a decent pattern. I think some of this is genetic, frankly. I've looked at enough of the literature regarding statins and these various other drugs that move LDL. I made my own decision that I was concerned enough about this risk that I wanted to jack up the MUFA content in my diet. And do I really know that the MUFAs did it? Well, no, because I don't have a before and after. But I do know plenty of other
Yeah,
people
you
who,
gotta eat. You gotta eat a bunch of ribeyes and do this again in
yeah,
six weeks.
I'm not what I want to. But I do think that there's enough of a strong association in between MUFAs. I mean, the PrediMed data, you probably have read about the PrediMed study. This is this famous New England Journal of Medicine article where they actually did a prospective randomized clinical trial with olive oil or nuts. It was done in Spain, and it was published in the New England Journal, and they showed a real benefit in terms of myocardial health. The study has been discredited because there was a problem with randomization, but even the corrected data, assuming you believe it, shows some benefit from with the addition of olive oil. So when I looked at PrediMed, I came to my own conclusion that it was probably beneficial. And so I've sort of just been following that idea.
Yeah, interesting. I think this is an area that we should have a deeper conversation about because I think the first battle is just having the argument that carbohydrate restriction is not going to kill you and that fat is
Right,
okay. So I
right.
think like we need to first win that first main battle, but I think that is like a sub battles or just further elucidation required in terms of the fat sources. I mean, I think personally I've been more focused on making sure my omega-3 to omega-6 ratio is better. I think that is a much more clear of a story narrative to me. I am just much more agnostic or just less educated around should I be concerned of LDL in of itself if I have high HDL, low triglycerides, if my C-reactive protein is low, if I haven't done a calcium coronary artery measure, but uh, hopefully that's zero. So I think so that's where I'm at in terms of that argument or line of thinking. I'm just I'm sort of agnostic or just less educated or less opinionated on MUFA versus PUFA versus saturated fat. But I think I think PUFAs we should probably likely avoid.
Yeah, especially when they're hot. I mean, it looks like, but the whole omega-3 story is quite interesting. And a lot of the fish oil studies have failed to show efficacy, including these big randomized controlled clinical trials, with the exception of this new, very specific omega-3. So there's this question of DHA versus EPA. EPA looks to be very effective, but that's a complicated story, and I don't know. We'll see more about this.
Yeah, we'll unpack that. Yeah, I think it. Yeah, I mean, I think that's the hard part about nutrition as a whole because it's something that is so chronic. I mean, it happens every day, multiple times a day, and there's so many factors that affects overall these endpoints. So I think that's why there's been so much controversy around something that's so fundamental. Like you would think that we figured out human nutrition because all of us eat and all of us have opinions on what if you think is good or bad. So I think that's just the nature of the field.
Though it's really important to at least get comfortable with the idea that you won't know. So the relative contribution of any one intervention is quite small, and ultimately you'll never have the certainty to understand this. There aren't 1,000 U's that you can then prospectively randomize to various interventions to understand which is better. Thinking about your health, thinking deliberately, having the luxury to think about your health. We have a range of options, frankly. I mean, I'm really privileged in that respect, right? I think there's plenty of other people who don't have as much variety or options to think about food.
Yeah. That I 100% agree with. Well, I feel like we could just go in a bunch of different rabbit holes here, but I want to be conscious of time as well as giving the opportunity for listeners tuning in. If there's areas that you want Jake and I to further explore, we'll definitely have you back on. But before we leave here, what are your current key interest areas, whether that's on the investment side or the research side? How do people stay in track and follow along? What are all the shout outs?
Okay, so we've been very interested in type 1 and type 2 diabetes. We actually have a big paper that we're trying to assemble on the beta cell's response to increased metabolic demand with type 2. So as I wind down my academic career, bizarrely, I have this huge paper, this magnum opus that we're attempting to write over the next 6 or 8 months. And we hope to essentially ask the question, what is the regenerative response in type 2 diabetes? And how does the beta cell lack of regenerative response contribute to metabolic decompensation? So we think we have a pretty good model for this. It uses autopsy specimens and with some amazing stuff. So that's something we're working on. And then in my professional role with the private equity firm with McNair Interests, we're currently we're sponsoring several companies that are trying to do really cutting edge stuff to push the envelope. So one that we're very excited about is this company Glycens, and they have this is all early in clinical trials that it's not FDA approved, but they hope to make a implantable CGM that would live inside your body for 18 months or 2 years and send a Bluetooth signal to your phone. And so I'm really proud of that investment. It's obviously, this is all public. They just had a Series F and our firm invested a bunch of money. But that kind of sort of moving, I mean, if you had something inside of you that was constantly sending a Bluetooth signal, I mean, it would be very cool, especially for people with type 1, because it might then allow you to, not have, I mean, there's real problems with
It's
the
it's giving
CGM
you a
falls
sixth
off.
sense. It's giving you a sixth
Yeah.
sense. It's giving you a sixth
Yeah.
sense of your physiology and metabolism.
And if that could be done, I don't know if it can, but if it could be done, it'd be fabulous. And I think it'd have a huge market. And then, in cancer immunology, we're very excited about a company. It's called Invectus, and they're moving from Paris, France. And so they're at the Pasteur Institute, and now they're going to open up a branch here in Houston, Texas. And they do some really cute things around common antigens. And we just won a huge $14 million award from the state of Texas, one of these so-called CPRIT grants. So it's a Cancer Prevention Research Institute grant, where the state of Texas gives money to a company to relocate. And so they do a really cool thing with one of these markers that may serve as a cloaking device for tumors. So tumors may be hiding from the immune system using this thing called HLA-G. And HLA-G is what the placenta uses to hide the baby, the developing baby, from the maternal immune system. So that's why I call it a cloaking device, like in Star Trek. And it turns out the cancer cells also use this mechanism. And so this company that we're involved with hopes to develop some HLA-G targeting therapies. I just think that's totally science fiction. It's great. So I'm way out of my comfort zone in reading about cancer immunology and but it's way fun.
Yeah, I mean, it sounds like hopefully, for the benefit of our society, that these bets or investments or science experiments work out. Because I would love it to be in a world where there's effective cancer therapeutics, right? So I mean,
Yeah,
if you guys
especially
win
for
there,
solid
I think we all
tumors.
win.
So I'm on Twitter. It's Jake Kushner, JakeKushner, MD, and I'm also on LinkedIn. That's the main thing. One way to get a hold of me. But people should feel free to write to me if they have questions, either on LinkedIn or on Twitter. I answer questions all the time. I'm happy to if people want to reach out.
Awesome. Well, truly, really a pleasure to speak with you today. Super fun conversation, going from kind of a history of science and the history of peer review to going into type 1, your research career, down to kind of this sci-fi of medicine in the
It's really
future.
fun.
So, a
Thank
super
you.
fun conversation. We'll have to have you back on, Dr. Jake.
Great talking with you.
Cool. Thanks so much.